Okay, so now that we understand what an object pool is and why we would want to use one, in this video, it's time to code it.
Right. So in this case, I think I'm going to put this one inside of features because this thing is generic enough that it's not going to be specific to the train system. It's just something that I'd like to have available for everything. So let's just throw it up here for now. If I find a better place for it later, we'll move it. That's the cool thing about refactoring. So we'll call this one My Object Pool. Go ahead and fire that off. Clean up the namespace. Now go ahead and kill system, and I can clean those up for now. Now this particular class is going to be a public static. I don't want to have multiple object pools. I just want one. So this will be our public static My Object Pool. Inside of here, we're going to have a private static read-only linked list, and it's going to save objects in it. Not Unity objects, just regular old plain objects. And I'm going to call this pulled objects. From here, I'll create a property that's going to be a public static. And this is going to return an int because this is going to be the count of objects that we have in our pool. So this will simply return our pooled objects.count. From here, we need a static constructor. So static myObjectPool. We'll use the static constructor to initialize our pooled objects. So that's going to equal a new linked list of type object. And then from here, we're going to have two methods. One's going to be a public static void. This will be our check-in method. And in here, we're going to pass in an object. We'll call it item. And we just simply add it to the last element of our linked list. So that's all we do for checking in. Checking out, slightly more complicated though. So what we're going to do is we're going to do a public static. This is going to return an object, and we're going to call it checkout. And this is going to be a generic. So it's going to be of type. Now, when we check out, we're basically asking it for a type. So we don't really care for a specific object. We don't care for any one of these objects. We just want one object of a particular type. So what we'll do is we'll iterate through our list of pulled objects, and we'll get our pull object, and we'll just go if pulled object dot get type equals type of t, basically the type that we sent into it. If that is the case, we're going to say pulled objects dot remove. We're going to remove that object from the list because it's no longer going to be available, and we're going to return that pulled object from this method. If for some reason we don't find an object of that type, we're going to return a default of that type. Whoops. Wow, that's pretty good. I missed a semicolon and ended up with a whole new linked list.
Yeah, you did.
It's like, how that's even possible, but whatever. All right, so that's it for the method. It's not very complicated for what it actually gives us. So to demonstrate what we can do with it, I'll go over to train demo. And for now, let's see, how can we demonstrate this? Let's go ahead and comment that out. And literally, we can do anything with this. So let's say I do a var s equals hello. So we'll use a string. And what else could I do? Let's do var equals new. Oh, not new. Let's do game up. How about game object equals game object dot create primitive and oops, primitive type dot sphere, and so that will give us a sphere, and then I can do stuff like my object pool dot check in. So I'm going to check in my string, my object pool dot check in my sphere. Now, this one ought to be fun. So let's do this here. Not here, but up here in awake.
By the way, everyone, just letting you know, Lee's just making this up on the fly.
You noticed? Basically, we agreed that S and Go are limited scope, right? So they only exist
Yeah.
inside of awake.
Mm-hmm.
So once they go away, they should completely go away, other than the sphere, because it'll still be visible. But I can then say go dot render dot enable equals false. So basically, I'm turning off its visibility. I'm checking these in. S and Go will no longer exist outside of here. But inside of start, I can then say var t equals my object pool dot checkout. Now I need a type. I want to type string. And then I'll cast this as a string. So that will give me t. Take debug.log, and then I will say debug log t. I can also do this and say go.name equals my sphere. So then I can go here, then say var, let's see, just different name, temp game object equals my object dot check out. I'm going to look for a game object this time, and as game object. So now I've got a game object. I can then take temp game object dot render dot enabled, turn it back on so it's visible again, and then I can take and debug dot log, and we'll log out the temp game object dot name. So what we should end up happening is in the awake, we're going to create a string called hello. We're going to create a sphere that we're going to call my sphere, and we're going to turn its visibility off. We're going to check both of those into the object pool. We're going to leave the awake method, which means the S and Go variables are going to lose scope. They're going to go away. Inside of start, I'm going to check out a new variable string, which is going to be from our pool. So this is going to be the same string that we checked in. I'm going to assign it to a new variable, and I'm going to print it out. So if this works correctly, we should see the word hello. I'm then going to check out a game object, turn its visibility back on, which means it should be a sphere. And while I'm at it, I'm going to take temp game object render.material.color, and I'm going to set its color to red. And then I'm going to print out its name. So it should come back out as the my sphere. So cross my fingers and hope that this works. So here we go. Hit play. I have a sphere. There's my sphere. If I zoom in, there's my red sphere. It's red. If I look at my debug log, there's hello and there's my sphere.
Very good.
So it is checking in. We're losing scope, but we do not lose the objects that we checked in. They're still existing. So we're not instantiating this anymore. The other thing that I can do to demonstrate what's going on is if I go into code again, ignore this. So if I go here and I do a debug.log, let's do ObjectPool count plus myObjectPool.count. So if I do a count here, followed by a count here, then let's do a count here and a count here. Jump in, go ahead and run. So we see we start off with 0, then we've got 2 objects because we had none in the start. We checked 2 objects in, we checked 1 out, printed hello, now we're down to 1 object. We checked out another object, now we're back down to 0 objects. So the objects are either in the pool or they're not. So once you check them out, they're no longer in the pool. So you're not instantiating or making copies of the same object over and over again. And likewise, once you check them in, it's your responsibility to make sure that you're done with them before you check them in. So if it's a game object and you need to hide its visibility or you need to do some cleanup before you check it into the pool, it's still your responsibility to check it in. The object pool does not do any cleanup for you. It's just a way of holding on to an object's reference so that you can retrieve it at a later point in time and reuse it. So,
And you're going to use this with the system as far as the terrain goes. I mean, it should be pretty obvious, but just in case somebody is missing the big picture on how you would go about using it.
right. Well, I can show that real quick. Let's again back to code. Let's go ahead and I'll delete all of this stuff. Whoops. And I can use the keyboard really. Let's go ahead and kill all of this. Let's create a single mesh. So I'll copy this. So inside of start. So here's our mesh. And I'm going to modify this mesh so we start off at a vector 3.0. So very specifically, it's going to create one mesh at the origin of our world. So there's our single mesh at the origin of the world. Now, let's say our character is moving around in the world and we're no longer needing this mesh. They've moved. Now, what I'll do is, again, I'm going to put this in awake because it's just easier than having to deal with the update.
Sure. So
I'll create the mesh in awake. I'm then going to say, I'm done with this mesh. So I'm going to say mesh dot render or mesh render dot enabled equals false. So go ahead and run this just to show that
we don't see a mesh, but
we
it's
don't
there.
see it. It's still here. We've just turned it off.
Right.
Saying we don't need it. So at this point, we don't need it. I've done the cleanup to make sure that we don't see it anymore. Now what I'm going to do is I'm going to check it in. So I'm going to say my object pool check in, and I'm going to check in our mesh. So our mesh is now checked in. We've done our cleanup. We've checked it in. Now let's say we want to use it somewhere else. Let's say this particular mesh needs to be reused because the character is moved, oh, let's say 100 units in Z. So we'll say var mesh reused equals our myObjectPool.checkout. We're going to say I need a train mesh. So give me a train mesh. And I'm going to cast it as a train mesh. So now that I have a train mesh, I'm going to say mesh reused dot update, and I'm going to update its position. So let's give it a new vector. So new vector 3, and I think I said I was going to move it 100 units in Z.
Right, you did.
So that's 100 units in Z. Then I'm going to turn its renderer back on. Dot enabled equals true. Okay, there. So basically, we've created a mesh. It's at 0. I've shown you that. I've disabled its renderer. I showed you that. I'm going to check it in. Then I'm going to check it out. I'm going to update its mesh, which is going to move its location, and then I'm going to turn it back on. Now, this is the same mesh. As you can see, I'm not creating any more meshes, just this one. So if I go ahead and run this, hit play, we've got a train patch, but I've moved it 100 units. Now you got to remember, I moved it in 100 mesh units, which is mesh units times the size times the spacing, with 4 times 9 being, what, 36?
Mm-hmm.
So 36 times 100 came up with 3,200. Not quite sure how that worked.
I was about to say, huh?
Yeah, well, get my handy dan. Yeah, that hurt my head. I need the calculator. So 9 times.
Where's your calculator?
30. Oh, it's 8 times. Oh, yeah. It's on my other screen.
The -1?
Yeah, it's that 8 times 4, 32. I forgot to subtract 1. So yeah, it's 3,200 units. So here's our camera right here, or our game manager, which we said was at 0, which is where that patch was. Here's where our patch is now. There it is. It's turned back on.
Very nice.
So it's there. There's our game manager. Well, hold on. That's more than our game manager. So here's our patch. There's our game manager. It's back in, and I've only got one patch, and I didn't recreate anything. There's no penalty in this other than the fact that it has to reassign those arrays, which are very fast, but it does also have to recalculate the mesh, which, depending on the size of your mesh, can get very expensive.
Which, again, is why we've done so much testing back and forth and looking for what the optimum size would be as far as the trade-off for time for the creation of the collider.
Right. So, but the cool thing with this ObjectPool is, like we were showing you, we can take any object, and when we're done with it, we can check it in, and then we can just bring it right back out at any point in time and repurpose it. We no longer get the penalty, because if you look at some of the code that we do in the train mesh, well, we've stripped out a lot of the intensive stuff, which is creating this base mesh and calculating all of the triangles and the UVs. And when we get into the vertex cache, we're going to be assigning heights and normals and tangents and colors. All of this is going to take time and memory. We've created the base mesh, so we've taken a lot of that calculation, so it's only done once for the entire game. This train mesh part is what is being done every single time we create a new mesh. So if we weren't using this object pool, every time you needed a new mesh, you would be creating a new object, assigning a bunch of components to it, setting some settings, creating new arrays, assigning values to other arrays. So all of this is taking up memory that the garbage collector then has to go and take care of, and then we have to do this update. Well, what we've done is we've taken all of this code and all of this memory requirement, and we've set it up so we're only doing it once for a mesh. So if that mesh isn't being used again, we just reuse that mesh again. If we're done with it, we reuse it. If for some reason all of the meshes are in use, then and only then do we create a new mesh for the system. And that will be the same thing with bullets, with explosions, possibly sound effects. So pretty much anything that is an object, and the last time I checked, everything in C# is an object, can be checked into this system.
Very cool.
So, but that should be it for the object pool. I think. You think I missed anything?
No, very good job. So from the object pool, you're looking at would probably visit the terrain patch next.
Right. The terrain patch is going. Its job is that's something that we will be creating new ones of. And basically, the terrain patch's job in life is to coordinate with the vertex cache to get the right information for the mesh. Its job is to basically, when you create a new terrain patch, it's going to go to the object pool to see if there's any meshes there that it can reuse. If there is, it'll reuse it. If it can't, it'll create a new one. It will then go to the vertex cache, ask the vertex cache to get the right height information, the right normal tangent information, color information to populate with the mesh. And then it will call the meshes update, as well as making sure that the mesh gets positioned in the right place.
Right.
So it's kind of the in-between from the train mesh and the train manager. The train manager job is coordinating the construction of these patches. If you remember all the code when I first started off in these sets of videos, when I opened up that train demo and wiped out all that code for panning and scrolling up and down, left and right, the train manager takes the place of that. And there's a whole new way, much more streamlined way in which I designate train patches to be created.
Sweet. All right. Well, fantastic. With that, I guess we can go ahead and bring this video to a close.
Yeah, I think so.
All right. Awesome. Well, ladies and gentlemen, thank you very much. And that concludes this video.